Assalamualikum OyaRahmatullahe OyaBarakatuhu. Innal hamdanillah wassalatu wassalamu ala rasulillah. Amma ba'd. Bismillahirrahmanirrahim. This is Muhammad Kamrul Hussain, Department of Business Administration, Metropolitan University, Sylhet. Welcome to my virtual classroom, MKA CLASSROOM. Now let's start today's video tutorial. Now let's start today's video tutorial for examples of risk measurement. In previous classes we have discussed about risk measurement process by the use of several formulas. Now here we will try to discuss examples of risk measurement process. So here has the examples. Norman Company's past estimates indicates that the probabilities for the pessimistic, most likely, and optimistic outcomes are 25%, 50%, and 25% respectively. Notice that some of these probabilities must equal to 100%. So you know it better that 100% should be the wall probability is equal to 100%. So here we will see the examples. Norman. Yes, we previously seen that asset A and asset B, pessimistic 13%, most likely 15%, optimistic 17%, B 7%, 15%, 23%. And here we have the information that this pessimistic is 25%, most likely 50%, and optimistic 25%. Now calculate the standard deviation over here we will see wants to choose the better of two investment A and B. Norman Company's examples we are discussing in previous classes. A and B are the two investments, and which one is better. Here has the two investments return. Here has the two investments three outcomes probabilities: pessimistic, most likely, and optimistic, 25%, 50%, and 25%. And which one is better? Now we have to calculate. So we will see for asset A, expected rate of return. So in previous classes we have learned the formula, so I am not going to write down that formula, so you can see the previous video, then where we will discuss the risks and risk measurement. Here we will measurement examples today's lectures. So you will see 25%, that means 0.25, 13% plus 0.50 into 15% plus 0.25, 17%. So here is our return. So we will see expected return by the calculating these examples. Our expected return should be, by the use of calculator, it shows 15%. Now standard deviation for asset A. I am not going to write down the formula, so you have to write down the formula, and you have to do in the exam in a well manner. Just I try to make you understand. So here we will see Rj minus R bar whole square into Prj root over, that is our formula. So here we will see 13% minus 15% whole square plus, here is obviously summation, plus 15% minus 15% whole square into 0.25 into 0.5 plus 17 minus 15% whole square into 0.25, then root over, wall root over. Then by the use of calculator, result will be 1.41 percentage, 1.41 percentage assets standard deviation A. Now we have to calculate for B. First we have to calculate expected rate of return R bar. 0.25 into 7% plus 0.50 15% plus 0.25 23. So by the calculating use of calculator, the result should be 15%. Now we have to calculate the standard deviation. Standard deviation 7% minus 15% whole square into 0.25 plus 15% minus 15% whole square into 0.5 plus 23 minus 15% whole square into 0.25. Then by the calculating these things, obviously you have to provide the root over, or sigma square, you can write down the sigma square, then after that calculating all of this, then you provide the root over, no problem. Result should be 5.66%. So here we will see A and B, here the two project expected rate of return 15%, it also the 15%, sigma or risks 1.41%, and here is 5.66%. These are the two stocks, standard deviation and expected rate of return. So in the rules, if our expected rate of return are different, then we have to calculate CV. but here expected rate of return is same. That's why we need not to calculate coefficient of variation. On the basis of standard deviation, we can call which one is less risky and which one is more risky. So here is a question to choice. So here is less standard deviation means less risks, and more standard deviation means more risks. So as a rules, if the standard deviation is less, it means less risks. If the standard deviation is high, it means risk is high. So from our calculations, we seeing that asset A has less risky. It has 1.41. It's a standard deviation. That means it is less risky than asset B. So whenever these two are mutually exclusive, that means you have to take one. We have to take asset A for our decision making. We will take asset A for our decision making. This all about today. Stay home, stay safe, try to maintain a safe social distance, try to wash your hands frequently in a day. Subhanaka Allahumma wa bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaika. Assalamualaikum warahmatullahi wabarakatuhu.